Hello friends, myself w.r.to. I am from sgm college Karan. In previous lecture, we were studied about integration by parts. In this lecture, we were studied corollary on integration by parts and examples of that corollary. Here is the corollary: integration of e raised to x into bracket f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Look at here. The corollary says that if there is a term of e raised to x inside the integration and in bracket there are terms of a function and whose derivative is there, f of x plus f dash of x dx, then such a type of integrations are evaluated as e raised to x into that function plus c. Okay, so first we prove this corollary. Question is asked as prove that integration of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Okay, first take integration. I can write here let I is equal to integration of e raised to x into f of x plus f dash of x dx. Okay, we solve this corollary or we prove this corollary by two or more methods. Okay, but one of the simplest method is here. Answer is what? E raised to x into f of x. Okay, so put for that function. Answer is what? E raised to x into f of x. So put for that function. Okay, so I can put for e raised to x into f of x is equal to new variable t. Okay, substituting e raised to x into f of x is equal to t. On differentiating, tell me, here we differentiate. Here is the term e raised to x into f of x. Into is there, so product is there. We use product rule. First as it is into integration of derivative of second. On differentiating, first as it is into derivative of second. Yes, f of x derivative is f dash of x plus second as it is into derivative of first. Derivative of first is e raised to x. Derivative of e raised to x is e raised to x. Since it is differentiated with respect to x, multiplied by dx is equal to derivative of t is 1. Since it is differentiated with respect to t, so multiplied it by dt. 1 into dt is dt. Taking what common? Okay, taking e raised to x common here and writing f of x first plus here is the second term f dash of x dx. Instead of that term we can write as dt and here is that term. Here is that term e raised to x into f of x plus f dash of x dx. Okay, so integration becomes I is equal to integration of, instead of that term we write only dt. Okay, now integration becomes I is equal to dt is nothing but integration of 1 into dt. Integration of 1 is with respect to x is x, but integration of 1 with respect to t is t plus constant of integration c. Our answer is in t. Yes, replace t by e raised to x into f of x. So e raised to x into f of x plus c, I is equal to, and what is I? I is nothing but integration of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus constant of integration c. Here is the proof of the corollary. But remember, substitute for that term. Answers e raised to x into f of x is equal to t. When we substitute e raised to x into f of x is equal to t, we get e raised to x into f of x plus f dash of x dx is equal to dt. Integration of 1 is t and replace t by e raised to x into f of x plus c. It's very simple to do. Okay, now here is example on that corollary. For example, if there is a integration of e raised to x into first term is tan x plus second term is sec square x, and in between this sign between these two terms is plus. Okay, remember here is the plus sign. Then we can directly evaluate such a type of integrations as writing e raised to x into, yes, tan x plus c. Since here is that function f of x and derivative of f of x is here, that is f dash of x, and we know that the formula for e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus constant of integration c. Okay, so it is very simple. So solving the examples on that corollary. Here is the first example on the corollary. Evaluate integration. Evaluate integration of e raised to x into 1 upon x minus 1 upon x square dx. Evaluate integration e raised to x into 1 upon x minus 1 upon x square dx. Look at here, the example is on integration, so denote first that integration by I. Okay, we know that the corollary is integration of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Look at here. Inside the integration there is term of e raised to x, so it is the clearly example on that type of corollary. Okay, so I can write here 1 upon x is a term plus there is middle sign is plus, so I can write here plus minus 1 upon x square dx. Look at here, 1 upon x, here is that function f of x plus, and here is derivative of 1 upon x. Derivative of 1 upon x is minus 1 upon x square. So e raised to x into f of x plus f dash of x. Answer is what? E raised to x into f of x. So directly I can write here, which is equal to directly e raised to x into f of x is what? 1 upon x plus constant of integrations. Here is the final answer. Okay, and write a reason. Since integration of e raised to x into bracket f of x plus f dash of x dx is equal to e raised to x into f of x plus c. This can be simplified as e raised to x divided by x plus constant of integration c. Here is the second, first example on the corollary. Next, evaluate integration. Evaluate integration e raised to x into bracket 2 plus cot x minus cosec square x minus cosec square x dx. Look at here, derivative of cot x minus cosec square x. So I can write this as, first denote the given integration by I, starting with let I is equal to integration of e raised to x into 2 plus cot x minus cosec square x, which is equal to, I can write this as e raised to x into 2 plus cot x. Okay, since derivative of 2 is 0 and cot x is cosec square x minus cosec square x, I can write this as plus minus cosec square x dx. Okay, here is the function. Here f of x is equal to 2 plus cot x and f dash of x is equal to, after differentiating derivative of 2 is 0 plus derivative of cot x is minus cosec square x, and we know that using what? Corollary, e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. So I is equal to, using this corollary here, answer is e raised to x into, what is the function here? It's 2 plus quad x. 2 plus quad x plus constant of integration c. Here is the answer. Okay, of second example, evaluate integration of e raised to x into 2 plus quad x minus cos x square x dx is e raised to x into 2 plus quad x plus constant of integration c. Okay, next example is here. Evaluate integration. Evaluate integration. In a numerator, there is 1 plus sin x, and in denominator there is term 1 plus cos x dx. Look at here. For using this corollary, here first term is e raised to x, and inside the bracket there is a addition of two functions. But here is division. I can convert that division into addition. Look at it. We know that 1 plus cos theta is equal to 1 plus cos theta is 2 cos square half of the angle theta by 2. Okay, and here is the term of sine. Angle is in half, so I can write sin theta as 2 sin theta by 2 into cos theta by 2. Okay, after simplification, first denote the given integration by I, where I is equal to e raised to x into 1 plus sin x divided by 1 plus cos x dx. Okay, which is equal to e raised to x into 1 as it is plus sin x can be written as 2 sin x by 2 into cos x by 2 divided, and 1 plus cos can be written as 2 cos square half of the angle, that is x by 2 dx. On separating denominator, when we separate the denominator, this looks like 1 upon 2 cos square x by 2 plus 2 sin x by 2 into cos x by 2 divided by 2 cos square x by 2. Okay, dx. After simplification, we write this as I is equal to integration of e raised to x into 1 upon cos is sec, so 1 upon cos square is sec square x by 2 divided by 2. Okay, plus 2 get cancelled, 1 cos get cancelled. What's remaining here? Sin x by 2 divided by cos x by 2, and sin upon cos is tan x by 2. Okay, dx. Now look at here. Derivative of tan x by 2 is, derivative of tan x is sec square x. Derivative of tan x by 2 is sec square x by 2 into ddx of x by 2. That is sec square x by 2 divided by 2. Okay. Here, f of x is equal to tan x by 2. Okay. Therefore, f dash of x is equal to what? Derivative of tan x by 2 is sec square x by 2 into derivative of x by 2, that is 1 upon 2, which is nothing but sec square x by 2 divided by 2. And we use the integration of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Okay, use this corollary. Therefore I is equal to integration, yes, integration I becomes e raised to x into, what is f of x is here? Tan x by 2, e raised to x into tan x by 2 plus constant of integration c. Okay, now moving to our next example, evaluate integration. Evaluate integration e raised to sin inverse x, e raised to sin inverse x into bracket x plus root of 1 minus x square, x plus root of 1 minus x square divided by root of 1 minus x square, root of 1 minus x square dx. Okay. Look at here. First, it is clearly example on integration. So denote that integration by I, starting with let I is equal to. Okay. In this example, we will clearly see that derivative of sin inverse x is root of derivative of sin inverse x is 1 upon root of 1 minus x square. That term is present there. Okay. So we solve this integration by substitution method. What is the substitution method? Yes. Put for the function whose derivative is there. Put for sin inverse x is equal to t. When we put, we differentiate. On differentiating, derivative of sin inverse x is 1 upon root of 1 minus x square into dx. Why dx is there? Since it is differentiated with respect to x, so multiplied by dx. Derivative of t is 1. Since it is differentiated with respect to t, multiplied by dt. RHS is in t, so differentiate with respect to t. Okay. And here is that term, 1 upon root of 1 minus x square is dt. Okay. So I can write this as I is equal to integration of e raised to sin inverse x is t into x. From this, I can write this as x is what? Taking sign on RHS, x is equal to sin t. Means I can write here sin t plus square root of 1 minus x square. What is x square? Sin t square. That is sin square t. And 1 upon root of 1 minus x square dx is nothing but dt. So our clearly example comes in new variable t. All the variables in above example, that is x, is converted in terms of t. So simplification is there, which is equal to e raised to t sin t plus 1 minus sin square x, 1 minus sin square theta, cos square theta. So square root of cos square t dt. Since sin square theta plus cos square theta is equal to 1 square root of cos square t. I can write this as e raised to t into sin t plus square root of cos square t is cos t dt. Okay. Now using that corollary here, f of t is what? F of t is equal to sin t, and derivative of sin t is cos t. F dash of t is equal to cos t, and we use the corollary e raised to t into f of t plus f dash of t dt is equal to e raised to t into f of t plus constant of integrations. Therefore I is equal to, okay, using that corollary, e raised to t into whose derivative is there? Sin t's derivative is cos t, and middle sign is plus. So e raised to t into sin t plus constant of integrations. Answer is in new variable t. Convert that new variable to old variable x. T is nothing but sin inverse x. Okay. E raised to sin inverse x into sin t is nothing but x plus constant of integration c. Here is the final answer of the given question. Okay. So it's very simple. You can write it from here directly. E raised to t, derivative of sin t is cos t. Answer is e raised to t into sin t. If you are not giving this explanation, it's already okay. Okay. Next, evaluate integration. Evaluate integration. Similar example on substitution. Evaluate integration. E raised to 5x into e raised to 5x into 5x log x plus 1, 5x log x plus 1 divided by x dx. Okay, look at here. in corollary, there is term e raised to t or e raised to x, but here is e raised to 5x. So I use here substitution method. Put 5x is equal to t. 5x is equal to t on a differentiate. 5 constant as it is. Derivative of x is 1 multiplied by dx. 5dx is equal to dt. Derivative of t is 1 equal to dt. So dx is dt divided by 5. And here from 5x is equal to t, we can find the value of x as t divided by 5. Okay, so integration becomes e raised to, instead of 5x I can write here t into bracket. Instead of 5x I can write t log x. X is what? T by 5. Okay, plus 1 divided by x. X is what? T divided by 5. Okay, and instead of dx it's a